as we have seen that refraction and how does it work, so there must be having the practical use of it. Here is the thing that is the most usable thing that we have seen and according to which we are capable to make others' life happy. Yes, and this is what is lens. So you have heard about lens. That lens that you have heard might be different according to my definition, but yes, lens is the thing that is made up of the glass. Okay, this is the transparent medium, transparent glass, and according to which we just cut it down into two equal pieces and two spherical surfaces are made out of it, and accordingly we are going to give them a shape. So this is a concave lens and this is a convex lens. Here it is a glass shape, and here you can see that here we are having a spherical shapes here, spherical boundaries here like this and here. So this, how does it going to help you? So this is what we are going to see here. According to the lens, you know that this is made up of glass, so light will travel from one medium to another medium here also and is going to bend, okay, accordingly and according to the refractive index of a glass. So here the glass that is being used here is a particular glass that is used for the making of spectacles. Lenses are of variety. Even you are not just using lenses in your spectacles but also in telescopes and microscopes. So here these are widely used and very, very useful for scientific researches. And that lenses, the quality that we are using, it depends upon the use of it. Okay, and accordingly that that the refractive index that we have seen just before the slide. So refractive index will give you an idea how much it is going to be bent. Okay, more or less. It depends upon the two things. One is the size of the lens and second is the material that has been used, or you can say the medium. Okay, so here the glass are also of variety. Okay, you are not having only one or two types of variety of glass, you are having a lot of variety, and according to the situation we are going to use it. But basically what you are going to do here, you just need to know that here what is lens. So lens are basically two types, that is concave and convex, and they are actually made up of spherical glass surfaces that is only combined with the two other one. Okay, this is one surface and it is combined with the other surface like this, and now it is a convex lens. One surface of this one and again this one is going to be joined like this. So this is concave lens. Okay, so here the surfaces are of spherical shape part like we have seen in the spherical mirror also. So that is combined together in this lens case. Earlier, in case of spherical mirror, we have just cut it down and polished it from one surfaces, but here we just cut two parts and combined them together to make it a one piece of lens. Okay, so this was the lens. Now let us see some important point for convex and concave lenses. You know that this is a concave lens and here we are having two spherical surfaces as I have told you. So this spherical surface and this spherical surface must be the part of a single sphere, big sphere. Let's suppose this was the sphere, and here if I have cut it down like this and together shift it to this side and joined it together like this. Okay, but you know that here the center for this surface would be here and for this surface would be here. So for this surface, this one will be here. So here the center for this one would be here and the center for this surface would be at this part. Okay, so here accordingly I just have drawn a diagram for you people. 2F is the center of curvature here. Okay, now F, you know that here F is the focus point where the light is going to be meet when it is going to be parallel to the principal axis. Same rule like we have seen in case of mirror here also follows. Okay, and we are going to discuss that also, don't worry. Okay, so here we are having focus points for both of the surfaces. F1 for this surface and F2 for this surface. Okay. Now, F1 and F2 are the focuses. According to the mirror, as we have seen earlier, you know that focus is the middle point in between the pole and the center of curvature. But instead of writing here center of curvature, what we have written here? Twice of focus. That is the length that is from O to F is the 2F, that is the twice of focus length, that is 2F, that is equals to center of curvature, but here we are not mentioning it. O, that is the part in between here also and here also. This is known as optical center. What we call it? Optical center point. You know that it is made up of glass, so it is fully filled with the glass material. That is why we call it as optical center, and this would work as a pole here, but here the rules for this optical center is different compared to the mirror. We are going to discuss that. Let us see the diagram for the convex lens. Now in this convex lens, as you can see, now again the light that is coming will going to bend and provide itself at the focus point. So one focus point would be here, and if the light is coming from this side, the focus point would be here. Okay, that is why here we are having two focuses. Why we are not just taking one focus like we have taken in the mirror? You know that light could come from both the sides. Okay, so here because you know that always we take light that is coming from left to right. Okay, that is the rule for that we have just defined as a standard one for reading the optics of the physics part. But in this case, in both these two cases, as you can see that light could be falling and bending towards here and could come from here also. So it could be make a focus point here also. But in this case, we are having different thing. Light is coming in this manner, so it is not going to be converge. Like this convex lens is known to be as the converging lens also. So the all light rays that is coming from this side, left to right, will be converge and focus at this focus point. But in this case, it is the diverging lens. It is known as diverging lens. So in this case, what is happening? All the lights that is coming from this side will be diverge in different direction like this. Okay, let me show it by diagram. Like this, light is coming like this and it is going to be diverge at a particular point, at a particular direction according to the refractive index. Okay, so it is going to be refract like this, but it seems, how does it seem? So where it is the focus point? It seems like the focus point is here, that it is coming from the back side of the lens and it is continuously coming like this. Okay, so it is treated like a straight line that is coming from a single point that is situated here. But in actual, it is all parallel lines that are going to be diverge here like this. So that is why we are keeping here two focus points, that light could be coming from here also or here also and here, because we are having two transparent surfaces. But in case of mirror, we were only having one reflecting surface. That is the only reflection thing. So that is why there were only one focus and one center of curvature, and here we are having two surfaces, two different surfaces. So we will take two different focus and two different center of curvature. Let me remind you once again that here the length from the optical center till the focus is the focal length, and twice of it, you know that is till the center of curvature or center of spherical glass. But here we are writing it as the 2F.